So you mean we add a talk?
Yeah, we'd like to, if possible, get
Uh-huh.
10 minutes
Uh-huh.
to get live info, which I think would be very, very useful in context of Teams 7084.
Okay.
So I don't know, maybe before variable Slack, so we can have the rest of the session for variable Slack.
Yeah, I think that it may be also a reason to stop the variable,
Yeah,
Slack debate.
actually,
If
that's
Yes, so like, so Martin almost done with the slides. We'll propose them in like 5 minutes. Okay.
okay.
So we like almost there. I just want to confirm that we continue.
yeah. I think we have. I mean, we have a pretty light agenda, so I think
So
Yes.
like in 10 minutes, wait.
you'll just just have you'll go last, and
Who does have the slides to?
I also.
I just had a revival process sample draft in mind.
okay.
Posted the list, prefix delegation, DNS.
We may need to start.
Yeah, I realize that. Just letting you know.
Just say a
Okay,
little
I'll take a look.
before the end of the
Now
week.
we finally
Yeah.
have a
I just want to say hello. I saw you for never chance. All right, I think it's about time to get started. So this is the IETF note well. Actually, you're in V6OPS, as you probably know. This is the IPv6, or this is the IETF note well. Everyone should read this and understand what it means. I'm going to go over it just because I think it's important. By participating in the IETF, you agree to the following processes and policies. You're aware that any IETF contribution is covered by patent or patents applications that are owned or controlled by you or your sponsor. You must disclose that fact or do not participate in the discussion. As a participant or an attendee to any IETF activity, you acknowledge that written audio, video, and photographic records of meetings may be made to the public. Personal information that you provide to IETF will be handled in accordance with the IETF privacy statement. And as a participant, you agree to be respectful and collaborative and just basically be nice to everybody, treat people as you want to be treated. And we are not your lawyers, so if you have questions, you should contact them. Next. That's a little bit housekeeping. Please use the QR code to sign into the blue sheet. That's how we will address the queue of questions. And if you're logged in, please use your mute your mic if you're remote, and get into the Meet Echo queue if you want to walk up to the microphone and ask questions. So we have a fairly light agenda today. The working group draft, there's only one that we're going to talk about. And we've got a handful of active individual drafts that we're going to go over as well. And then we have a late edition that's actually not on there that will go last. This is just some V6OPS status. We've been pretty active. I think we're, trying to keep up with modern times. Lots of progress on things like dual stack to IPv6 only. That's sort of a major push that is happening across the industry. There's several RFCs that aid in that, 8925 and 8950. We have some draft submissions for IPv6 mostly network deployment and operations considerations that I would encourage folks to look at. We have several last call and in the RFC editor queue drafts that I would also encourage folks to look at. And there's a handful of others that have passed working group last call as well. Go back real quick. I just want to note that we set the milestones. I would also encourage folks to go look at that, and further on down the slides, I'm going to ask people to start helping contribute to those. And that is this slide. So call for contribution to what we consider to be important works. If you're in the group and you're participating, we encourage and hereby solicit, contributions to the milestones. It helps us track our progress, and it helps us understand like where we think the industry is going and where folks want to get what they want to get to. There's the free IPv6 textbook that now has an ISBN number, so it's a real book now. It's open source. That's the GitHub repo, and I would also encourage folks to read that and contribute to it if they see that there are things that need to be added or adjusted. It's even been copy edited at this point, so if you find anything else in there, it would be really good to know. We can make those adjustments. Other tasks that we have and we'd like to work on, and again, feedback is definitely welcome here. We want to define and compare IPv6 deployment workload versus IPv4, so we better understand what that looks like and how we can improve, make IPv6 easier. We want to work with the Happy Eyeballs team to figure out how to see when Happy Eyeballs is invoked and to better understand what that process looks like for troubleshooting purposes and for tracking and just understanding how the process happens when there may be errors or not along the transaction. We'd like to measure DNS query speed and connection setup speed in IPv4 versus IPv6. I think this is some pretty important data that we'll need to keep track of over time. So we need a good way to get started on that. Any contributions definitely welcome. And we'd like to collect IPv6 traffic statistics, correlate those with user info, identify any potential issues. We want to measure the number of Internet of Things that's using IPv6, which I think is something that's a little bit further behind. And one that's particularly near and dear to my heart, education for IT practitioners, not just network engineers, about IPv6, get them familiarized with it. So building the drafts and the tools and the mechanisms for better educating people will only serve to get IPv6 deployed faster, further, and more efficiently. Go ahead.
Okay. If there's no more questions, then we will move on to the first draft.
Hey everyone, I'm here to talk about Jen and I's CLAT node recommendations. Next, please. So we just adopted it. Thank you, everyone. So I'm going to go, the next couple slides, we'll go through the changes that happened since the last IETF to make that happen. Terminology changes, including defining native IPv4 explicitly because we were taking some things for granted. About being able to get direct IPv4 connectivity. We replaced the term session where we meant use of the same IPv4 tuple for end-to-end, meaning in the context of not changing the source address used, et cetera, with several other edits to terminology to make it clearer. Next slide, please. The requirement was elevated from should not to must not for continuing to use CLAT when native IPv4 is available, because of the context of the attacks that this can prevent, with an escape hatch so that explicit configuration by an administrator of a node would allow them to choose to do that when it makes sense based on list discussion around IPv4 as a service in Japan, as an example, still being preferable sometimes for performance reasons, even when there's native IPv4 available. Next slide, please. And then changing what IPv4 availability means, specifying that we're talking about anything from DHCP or a non-link local address, although more on that here in the open items here in a moment, and clarify that the IPv4 only.ARPA queries 7050 style are to be sent to a resolver that's associated with the network, which is something most of us probably silently took for granted, but should be written down for those new to the area. You can't just send that to any DNS resolver. Next slide, please. Actually, this is a decent spot. I can take the question in the queue and leave this visual aid up for the state diagram that's in there. You can stay on the previous slide, and Sony, we can take a question. This is a good pause.
Oh, there is a question in the queue.
Is this right? Hi. Yeah. So about this diagram, it's so like option 108. It should be sent by the client. Yes. Like
Yes.
RFC 8925 says it should be sent by the client. We read the draft. We feel like the draft is a little bit confused about this part of sending option 108.
In what way do you think it's confused? As illustrated here, this 108 present is about the response. We send it always. The wait for the DHCP offer is to wait to see if we get 108 back.
Yes, it's we didn't read it. It's a little bit confusing, like so the only part we saw in the draft was that the router should handle option 108, and that should be configurable. We didn't see anything saying the client node needs to send it.
Okay.
So I think Jen may have an answer to that.
Yeah, Jen Linkova is a co-author. First of all, please send us an email if you have any concerns or confusion about this, but just to give you an overall picture, client requests option 108, DHCP server might or might not respond with option 108, right? It depends on the network configuration. However, please keep in mind that this draft is not strictly speaking about option 108. It's about when or disable or enable CLAT. This draft would be applicable even if the client does not support option 108 and just sits on V6 only network, for example, network which does not provide any IPv4 at all, right? We're adding option 108 to the picture because it's most common deployment scenario, and I will be presenting another draft about that, right? And we just want to make sure that if network actually has V4 and client is going to use V4, CLAT is getting disabled. I'm not sure if I managed to unconfuse you, but we can continue the discussion in email or on the list, please.
Okay. We have another question. We are working on an idea which we call SLAT in libc. So like, well, the idea is to provide SLAT support for IPv6 only operating systems. So instead of having the SLAT as part of the operating system, we move it to the libc. Does this have an?
So I think let's let Tommy finish his slides, and we can pick up the rest of this question line on the list.
Oh, okay.
Thank you.
Next slide, please. Okay, perfect. So we have a couple of open issues, most important of which is there seems to be a lack of consensus around what this terminology actually is. 70% of survey participants at this IETF say CLAT or CLOT or some vowel form in between. Some say CLAT, some say CLOT, some vowel form in between. Letting accents slide, this is a pretty serious differentiator, with one respondent giving a wildly different pronunciation of roughly who cares. Thanks to Xsamba for allowing us to write this out without using Unicode for the pronunciation. So we can put this into the text. Thoughts on the list, please, on which is correct. Next slide, please. There's an open PR for using IPv4 default route as a detection of do we have native IPv4, as opposed to doing an address type check of non-link local, which is currently in place, which seems pretty reasonable. Thoughts are welcome there in terms of, are these equivalent? Is there an edge case we haven't thought about, et cetera? Couple of open issues for, should we give a may that guides implementers on why they want to choose checksum neutral, but maybe they don't want to because? There's some open discussion on that item if that interests you. And a terminology issue around consistency between PLAT versus NAT64, because we tried to declare those interchangeable and that has not panned out. Go ahead.
A quick update. I yesterday opened another PR because I don't know if how much we trust the implementers. We might actually make it explicit that your IPv4 interface should has 20 bytes lower MTU than outgoing IPv6 one to prevent unnecessary fragmentation issues. It's not in the text, it's just a PR I realized we need yesterday.
Thank you. Yeah, that's it. That's good. So please go check that out too. Next slide, please. Couple of things that spawned off different drafts. This slide is also out of date. The first will be discussed later today in DNSOP, where I've written a draft that updates RFC 7050 that says, hey, the current definition for communicating with DNS64 securely is defined as use IPsec or something link local, shrug. And we can do better than that now that we have encrypted DNS standards and now that we have the network able to directly advertise its encrypted DNS configurations using DNR. But Jen has something to say before we get to the other issue.
No, I'm going to comment on issue number 13. So
go for it.
So the problem of presenting on Thursday is that by that time everything has changed.
Yes.
So we presented this draft at Interior. It overlaps a lot with Bill's draft. Where is Bill? Somewhere around. Yeah. So after discussing it with int area chairs and AD, what we're probably gonna do, we might spin another draft in V6OPS, which will be using Bill's SMP extensions which exist, but just update 7915, which is basically a translation algorithm talking about how to translate and how to add those extensions when you translate V6 to V4. So this is issue slightly outdated, so wait for another draft in V6OPS.
So ignore this link, but the issue on this draft's GitHub, I will update with the new link so you can follow along there for those following along at home.
So we have another question in the queue. You want to take it now or you want to wait till the end?
Next slide, please. I think I'm almost at the end anyway.
Okay.
Yeah. So thank you, everyone. Let's do the queue.
All right. So Shinobu, did you have a question for the
Hi,
speakers?
I'm Masanobu from NEC Platforms. Could you go back to the slide 6? Yeah. As a 464 XLAT author, I expected it called CLAT.
Okay.
So let's call CLAT.
Awesome. Source of authority.
And could you show slide 8? Yeah, issue number 13. I had a conversation with Jen yesterday. Then I have a different implementation without ICMP extension. So it's V4, V6 mixed route, trace route. So it doesn't need ICMP extension. Then Jen said it's a general, right? But I was thinking again, it's also general. So I want to share the implementation on the list. Let's talk about it on the list. Yeah.
Sounds good. A popular problem to solve, it sounds like. Cool. Anyone else?
There are no more questions in the queue.
See you on the list. Thank you.
Thanks. Next, we have Tim Winters talk about IPv6 CE routers.
Okay. This is, we presented on this last IETF, and this is just a continuation of that, basically, effort. This is updating 7084. Just a reminder for everyone, these are CE, IPv6 CE, which means customer edge routers. So these are things that ISPs basically deploy to houses. And then we wrote this spec originally. The first one was 6024. So this will be the third update of this document. Go ahead to the next slide. Couple things. So the third version of the draft, we updated it to a BCP. It was informational. We talked about this last time. Everyone seemed to be on board. So we changed that to a BCP. We added text. We had a nice conversation the last IETF about NTP and just clarifying that in this case, it's really just relaying the NTP information to the LAN. We do not want an NTP server in the box, but we do want to tell people, hey, you should just take the info you learn on the WAN and pass it along, basically. So we added that text. We added some text for, should support 9131, which is first hop routers, getting them in the neighbor cache. We think that's probably a good idea. And then the last thing, originally we up-leveled S2, which is ingress filtering. This is to stop spoof attacks. So this is something in your house is generating a bunch of addresses. We want the home router to shoot those dead. So originally in the original version of this, actually in 6024, this was a must. And then it got downgraded in 7084. And now we want to bring it back because we think people can do a better job and know how to do this now. So we upgraded it. The one thing feedback we got last time was it should be enabled by default, and then people should have the ability to turn this off if for some reason they don't want to be shooting things down. So those were the main updates we made. Next slide. I think it's really just, oh, yeah. So here's a couple things that me and my co-authors, two of them are here too. Feel free, guys, Ben and Jordy, to get up and yell things at me. These are the drafts that we're kind of looking at right now for potentially evaluating. Jen, got some thoughts for me?
No, and just, yes, so we talking about what to do in terms of Slack, renum, truth, and unique link locals. So stay tuned, like in the next few weeks, there will be updates.
Right.
So yeah, I guess the message will be the same. It's just basically a question how that information will be split between different drafts, yeah. So I obviously very, very happy to see that you're considering it. I'm just saying you that drafts might change. But I just, while I'm here, I really love this work. Thank you. I'm surprised it's not adopted yet.
Yeah, I mean, we're going to ask for that at the end of this. But yeah, I mean, it's obviously it's a working group milestone too. So I'm feeling pretty good about getting adopted. So yeah, we'll ask for that too. The other one on here is obviously the draft that is a working group document is the CPE LAN PD. I think you've seen some text about that or some emails about that this week. That's another one we're going to hopefully get to working group last call, and then we can wrap that up. I don't think we're going to want to include that in 7084 right off the bat because it's too new, but I think we could talk about that. It maybe it'll depend on how long it takes us to get this wrapped up. So those are the draft candidates, and then go to the last slide. I think the rest is just anyone has any additional comments.
Is there one more slide?
There's one more, I think. Yeah.
There we go.
Yeah. So questions. Go ahead.
I don't
Lorenzo.
think the page will load in time for me to click my hand. Sorry, it's so slow. Lorenzo Colidi, I was thinking about the sort of should be able to disable the firewall. I'm not a fan of like ingress filtering enabled by default. Can we have like must allow user to enable if device has UI or something? Because I mean, otherwise you've got these CPs where, like I have a CP that's provided by the ISP, and it has a fiber port, and it's got an ONU key that I can't get at. And if that had a firewall, I just would not be able to do incoming connectivity at all. Fortunately, it does have a way for me to enable the firewall. But I think I could get like, you have these CPU routers that use a CAN control, and then maybe that's fine.
Yeah. All right, I'll take that. Maybe I can come up with some text that will get us out of that. I understand the general feeling. Yeah, I mean, by default, we want to stop spoofing, but I get there are use cases where people know what they're doing.
Hi, I'm Masanobu from NEC Platforms. Could you consider to add IPv6 UPnP? Because in Japan, IPv6 UPnP is increasing now for the gaming, and we also observed the IPv6 UPnP implementation, Germany, France, etc. That's why we should discuss about it.
So I've been on a personal mission to try to kill that. So it's not my favorite, but I mean, yeah, we had some text in there if you go look about this originally. And part of the problem is UPnP, I don't think currently has a forum, is my understanding. So it's totally full rogue. So I want to say as little about it as possible.
Maybe we don't need the requirement, maybe just some information.
So, right, like we
added
some text about PCP for port control, right? And that's obviously the IETF's solution to this problem. So that's what we have in there now. I think what we say about UPnP, I'd have to go back and look. I think we might have, I don't know if Jordy or Ben remember, I think I might have taken out all of the text about it. I'll go look to see maybe if I can put something not very specific in there to get, I mean, maybe I just won't change it from what 7084 had.
Okay, thanks.
Good feedback.
Suresh?
Suresh Krishnan. Yeah, thanks. Just going back to Lorenzo's point, right? Like I think the ingress filtering, the text is very clear on what ingress filtering it is. It's pretty much BCP 38, right? Like, so it's just ingress, like a source address spoofing filtering.
Yes.
So it's not a default closed firewall, Lorenzo, just to make sure that that's clear, right? Like,
right. I should have said that. Yes. It's not the regular firewall, like a 1692 simple security one.
Ted?
Ted Lemon. So just on the topic of, I guess, ingress filtering and PCP and UPnP, whatever that is, because there isn't a spec, meaningfully there isn't a spec as to what requiring UPnP would mean. We should not mention UPnP. That is not an IETF spec, and in order to mention UPnP, we would have to specify precisely what we mean by UPnP, because it's actually a giant attack surface with only one thing that we care about in it.
Yeah.
I mean, I'm preaching to the choir here, but
yeah.
The point is, so Matter, for example, the Matter working group, as I understand it, is working on adopting PCP, and PCP totally solves this problem in a really good way. And it also addresses the problem of that Lorenzo's talking about with opening up ports on the outside in a programmatic way, so that we don't have the situation where end users are in a default open situation and have no way to control it. So I just think that we should require PCP, not make it optional.
Oh boy.
Yeah, no, seriously, we should require PCP, and that solves this problem.
So a couple things I'm going to say about that. I have, I don't know, somewhere hundreds of CPEs sitting in my lab. I don't have one of them that does PCP.
Right, and the reason we don't is because RRC 7084 doesn't require it.
I mean, okay, we can.
Seriously, like that's why.
I mean, yeah, okay.
It is not hard to implement. It's way easier than UPnP, but nobody implements it because nobody ever like got dinged for not having it in their implementation.
All right, I'll take that feedback and consider it. My instinct here is definitely to start with the should here. I think going straight to must is wild and crazy, but maybe we should be a little bit, I don't even think we say should right now. So we clearly should up level this.
So speaking as somebody who's like constantly being burned by routers that don't support this, as a vendor who doesn't unfortunately sell routers anymore.
Yeah.
It's really a problem that UPnP is, or sorry, UPnP.
PCP.
The PCP.
Do you support it?
Do we support, what do you mean?
Your vendor, you said. Do you support
If PCP is present,
is that a no?
if PCP is present in the router, then yeah, it'll work. Yeah, no, we support it. I mean, it works.
If it's in the router, though,
If
right?
it's in, I mean, we need a router to implement it in order to
you
use
do.
it, right?
It doesn't
So-
work without the router, so okay.
Yeah. So no, I mean, I think that the only way this is ever going to proceed is if it's required, and I don't see any reason not to require it. Like, what would be the exception for the should?
That's what I have to think about. I mean, maybe complexity would be the only thing interacting with the
But
firewall.
it's not that
from-
complicated.
Well, you've not met my CPE vendors, but okay, we'll talk.
That is not our problem.
I mean,
Well, let me rephrase that.
okay.
That's our problem in the sense that it really sucks that they're not doing all of this complicated stuff, but it's not that complicated.
All right. I hear you, Ted.
Yeah.
We'll think about that.
I think Tim is saying that it will be our problem once bad implementations
Yes.
are rife, if that might happen.
Yes,
if
that
would
is my
happen.
primary
Yeah.
concern.
So a couple of points. I would like to note that unfortunately, if hosts implement PCP, they must prefer PCP NAT64 detection over Pref64. Unfortunately.
Okay.
So yeah, we might have to update a 6-man document if we don't like that. That was a compromise that was made when Pref64 option was defined.
Okay.
Another thing I wanted to respond to Suresh about, when you say the text is very clear, I'm going to read the text.
Uh-oh,
The
this
CE
doesn't end well.
router is expected to offer mechanisms to filter traffic entering the customer network. However, the method by which vendors implement configurable packet filtering is beyond the scope of this document. Security requirements, 1, 2, and the third one is this: if the IPv6 CE router firewall is configured to filter incoming tunnel data, the firewall should provide the capability to filter decapsulated tunnel. So, yeah, it's I mean, this document takes no position on whether such functionality is enabled by default or mechanisms by which users would configure it. I mean,
Yeah.
I don't think it's very clear.
Can I answer that?
Quick
just-
reminder, and please announce who you
Okay,
are when you come to the
Suresh
mic.
Krishnan just responding to Lorenzo. I was specifically talking about S2, right? Which
Yes,
is which is the
specifically
change
about
that he was
S2.
talking about. Yes.
So Warren Kamari.
Hey.
So something that some other documents have done have said things like, in the next version of the spec, we intend to support PCP or require PCP or something like that. So we
That's an
could,
interesting
I mean,
thought.
it is very much like weasel words, but we could signal that we're gonna like require it real soon, and maybe that will help vendors to
Yeah,
start deploying. But then we'll have to actually, update the document.
Yeah,
fairly
that's a
soon.
good thought. No, we did that a little bit with the US Gov profile stuff too, once upon a time. So that's a good thought.
Jordi Palet, as a co-author of the document, I just thought, hearing about the Mother thing, if Mother is requiring PCP, maybe what we need to do in the document is to change our should for PCP for a should for Mother. So if Mother is expected to be available in the CE, then Mother is already requiring PCP. Maybe that's one way to sort it out.
Okay. Well, yeah, consider.
Tommy Jensen, Microsoft. Actually, to counter Ted's point, I actually liked that you mentioned UPnP because it makes the document more realistic for everyone outside the IETF, because it is a thing, and just acknowledging the current state of affairs, I think, is very useful. Please keep it.
Okay.
+1 to what Lorenzo was saying about PCP, there are a lot of widespread. I'm not saying therefore we shouldn't do it, but that's a much bigger than this document that cascades everywhere. If PCP is going to become a should or a must, it affects how we operate in other spaces too. And I'd like to experiment to see how that actually works first.
Lorenzo Colletti, sort of somewhat unrelated, but outside this scope, sort of on cellular networks in particular, one thing that folks may not know is that the cost of maintaining connectivity on cellular networks with Keep Alive is very high. A lot of carriers have like very, very, very low NAT timeouts for IPv6, even UDP, like sub-minute, and that is extremely expensive power-wise. It might be worth trying to explore using PCP to fix these problems. I don't know though if PCP supports programming outgoing connectivity as well. If it's only like open this port for me and it's not going to work, but if it's like, don't time out this session, please, thank you very much, then that would be useful for that as well. And it would be a reason to implement that on host as well, because modem battery life is super, super, super big problem.
I don't remember offhand, Lorenzo. That's a good question. Okay. That's
John
cute.
Peng?
Oh, and we got one remote. Okay.
Okay, can you hear me?
Yeah,
Yes.
we can hear you.
Yes, my comments is about the DHCP-PD for the downstream port. I think that the CE router should support DHCP-PD for as a downstream port to delegate the prefix to its downstream CE routers, because in many home networking there may be two tiers of CE routers. So the high layer CE router need to delegate prefix to its second layer router. Can you understand my question?
Yeah, so the PD part of this, right, my PD draft, right, says, hey, if you get something from your ISP that you should advertise it, you should take those prefixes if you have more than a /64, which I hope every ISP is doing, and then you should prefix those out to other routers. So in that, I think what you are asking me is if there's 270/84 routers, plugged in, cascading is what we usually call it. If that's happening, the second one should get a prefix from the first one.
Okay, thank you.
So we still support that model. It's kind of odd because we don't really have a great definition for that middle router at that point because it's no longer at the edge.
Okay.
No. Well, so the PD draft says you should put the right routes in and do the right things, and I hope that's what happens. So yeah, my last thing is just we would as authors would love to have this adopted as a working group draft. So
some really good discussion here. I encourage folks to continue it on the list. Next, we have Jen talking about some deployment and operations considerations for IPv6 mostly networks. Oh.
Anyway, hello, this is another update on V6 mostly deployment and operational considerations. Next slide, please. Yeah, so a quick recap. I don't know how many of you were in the room last time. I spent most of my time recently deploying V6 mostly and dealing with all those interesting details. And I was advised that it might be a good idea to document how to do this, because I assumed everyone knows how to do that, but apparently not. So this document basically talking about how you deploy V6 mostly, what's the benefit of it, what you should consider when you deploy it, and what kind of systematic issues you could expect. Obviously, the draft is not talking about like what kind of vendor bugs you're going to encounter, because it's a number limited field. It was a presentation last time with many details about the draft, but now I'm just presenting an update. Next slide, please. Yes, next slide. So what changed since we met last time? Yeah, so security consideration sections were added. Yes. So the key points are that when you do not have a safety net of IPv4, all IPv6 issues or attacks will be definitely much more visible, right? In dual stack network, nobody cares if your V6 doesn't work. But if you do not have V4, it's obviously a problem. The main new attack vector in V6 mostly would be if an attacker managed to spoof NAT6 for presence, right? So as a result, it could either cause denial of service if that spoofed NAT6 prefix is not routed anywhere and NAT6 is not on the network, or in the worst case scenario, if attacker managed somehow to redirect the traffic to themselves, it could be a man in the middle. Well, mitigation as usual, make sure your array guard is in place. And again, we recommend using pref64 option in array to detect NAT64 presence, not DNS RFC74 method, because obviously it's much more secure. And also, as Tommy already presented, the recommendation is that CLAT shall be disabled, must be disabled, sorry, as soon as IPv4 is detected. And obviously, the main motivation is that if the network is not actually V6 mostly, but dual stack, it's likely that your V6 security is not as good as it should be. Next slide, please. Yeah, so we added more like known issues. It was pointed out, I think during the right presentation, that it might be some IPv4 dependencies in your network admission control. Namely, a wireless access infrastructure is known to block devices if the infrastructure does not see DHCP exchange completed successfully. This obviously might be. It's not like it's something you should test before you enable this, right? Let me put it that way, right? It's not a fundamental unsolvable issue, but it's something you might encounter. Tommy already mentioned that operations team and users might be confused when they do not see any hops in traceroute. Users would complain that you have a packet loss when you actually do not. I mean data packet loss, because traceroute packets are definitely lost. So yes, again, slides are slightly outdated, but anyway, there is a work going on to fix this. Actually, the problem in that draft about ICMP translation is not limited to traceroute. It would also affect PASM2 discovery. Because if you receive an ICMP error, like a packet too big from intermediate V6 only hop, you could not translate it, you could not send it to CLAT, which means PASM2 discovery gets even more broken. I had some discussion about, you probably should not have any MTU issue in V6 only part of your network, and if you do, it's your fault. Well, I can imagine some cases when, for example, I don't know, your backup connectivity to your NAT64 at the edge of your network might go through some tunnels, and you do not use it most of the time, but for 1% of the time it's happening. So again, PASM2 discovery is kind of broken, but if you manage to receive that ICMP packet, well, it's such a miracle that it would be shame to drop it. So we're trying to do something about translating it properly and delivering it to the V4 application. Next slide, please. Yeah, a few open issues which have not been resolved in the draft yet. Next slide. Yes, so currently the document is like mostly operational. I'm a simple network operator. I do not deal with applications too much, so the draft is mostly talking what the network engineer should configure. We basically do not talk much about what applications should do, right? However, I don't know, maybe it makes sense to add some recommendations which might help network operators to create a list of requirements when they talk to software vendors. Next slide, please. Yeah, again, favorite topic, DNS versus DNS6.4. So DNS6.4 currently, when you deploy V6, mostly would do two things. First of all, it would allow your applications like CLAT and API, which does local synthesis, to discover which prefix to use for local synthesis. Again, currently, there is no reason to use DNS6.4 except historical, because your network shall be able to provide you that prefix in array. As far as I know, the vast majority of the widely deployed routing platforms are capable of sending prefix for a router advertisement. And also, if you do an RFC 7050, you also need to do RFC 8880, which tells you that if your application is using third-party resolver, not one provided by the network, please use network-provided resolver to resolve IPv4 only ARPA. Because I've seen many cases of brokenness when you configure your browser or your application is using DNS over TLS to some other resolvers, which are not DNS6.4, obviously, and everything gets broken. So basically, yeah, RFC 7050 is much harder than people might think, and it's not secure, so probably we should not be using DNS6.4 for detecting pref6.4. Well, if you have a proper application which only using names, now never does V4 literals and so on, those applications might just use DNS6.4 to get a synthesized records and so on. So it's a second function of DNS6.4. Next slide, please. The draft currently recommends that it actually goes back to that discussion, shall we provide any recommendations to applications? So local synthesis and CLAT should be performed using pref6.4 from array, and which means we only currently need DNS6.4 for two cases, right? You have a host like, I don't know, Linux laptop, which does not have CLAT, so it would rely on DNS6.4. However, again, only some applications would use it. So a lot of things will be still broken. For example, Stan, if you don't use relays for your WebRTC, because Stan fundamentally uses IPv4 literals and nothing can be done about that, right? Or if your host does not support RFC 8781 for detecting pref6.4 in array. So to sum it up, practically, I think in some cases it should be possible right now to have V6 mostly network without DNS6.4 if you only using operating systems which have CLAT and send option 108. So RIPE, in the last RIPE meeting, it was an experiment for disabling DNS6.4 on the V6 mostly network for like 1 day, I think. So as far as I know, if you speak about modern operating systems, the only few cases discovered were like some Linux laptops which had IP option 108 enabled, and it's not the default configuration, right? So if you rely on default configuration on endpoints, most likely you would not even need DNS6.4 currently. But if you expect your users to be like geeks who might actually enable, for example, go to configuration on Linux or enable option 108, you might still need it. But yeah, it would be, I think it would be great to get rid of DNS requirements for DNS6.4 because it's a hacky way, right? It does not solve all your problems. It creates issues with DNSSEC and so on. So it used to be useful, but I would really like to see it like slowly dying. Next slide, please. Yeah, so I think last time I presented this idea of using globally unique link locals when your link local address of default gateway actually specific to a, well, you can say it VLAN or mobility domain. So basically subset of network segments between which your host might roam. Like, for example, if you have .1x with dynamic VLAN assignment, and your host might move between those VLAN on wired network, it would be nice if each router has its own globally unique link local address. So it's, I'd like to hear the opinions. We can still have those operational recommendations in the separate draft, or those recommendations could be merged into V6 mostly document. The reason why I'm a bit concerned about just expanding the section is that actually a lot of text clarifying why it's all needed, right? So I think it might be a bit too much for a section in this document. So the thing is, currently the draft kind of talks about what you can do operationally. For example, what I'm doing in the network, I'm just manually, automatically using some automation, configure VRRP link local addresses based on the prefix, right? Anyone can do that if you configure your router manually. However, the draft has second part about some CPE routers, for example, or not even CPE, any router can do something like that automatically, and this is kind of goes to 6man. And we're discussing about merging it into Slack enum, because it's about how the router generates its local address. So it's a kind of gray area between 6man and V6OPS. So I would like to hear opinions. Would you like to see very extended section in this draft, or we can keep it as V6OPS separate one? Next slide, please. Oh yeah, that's all. I would really like to hear comments, feedback, especially if you have deployed something like that. And I would love to consider adoption, if chairs and the group could consider adopting this. Run, Warren, run.
Lauren Kamari. The Gula stuff is cool, but I think it should be in a separate document. Like we should get this one done and shipped, and the other we can get done and shipped too. But
Eric Venk, I will be basically repeating or echoing what Warren said, but the two documents, specifically if this one is called IPv6 mostly, and some people will not read an IPv6 mostly document to fix the Gula.
Okay, very fair point. Yeah, thank you. Also, yeah, it would be another draft again in V6OPS. I'm going to keep you busy, guys.
I think you previously mentioned the fact that I think in 6man, the sort of Slack renum stuff, not requiring the routers to put all of the data in the RA. And you wanted to sort of remove that text because of unique link local. I think one thing that we were talking about with David is about how was about how to implement Rule 5.5 in the Linux kernel, and it was like really complicated. And he came up with this scenario where a router basically sends you like alternate data. You know, in some arrays it just sends you the PIO. In some arrays it just sends you the RIO, and it's like changed its mind every 5 minutes, and that was really hard to implement. So
the same router, you mean?
Yes.
Well, let's assume we're talking about the same router, and the router is identified by the given link local address.
As
Should
long as
probably send everything together. How about?
Yes, as long as
it
you're
better?
clear that it's per link local address,
Yeah.
like perceived router from the host side, as opposed to actual hardware box, I think that's fine.
Well, like two virtual routers, you can tell, right? If it's the same router or not. As long as link local addresses are different, you should treat it as a different router. So,
Any other questions?
no, done, good. Thank you very much.
Excellent. Again.
Hello.
Are you there?
Yes. Yes, I'm here. Can you hear me?
Yeah, you're a little bit quiet.
Sorry, can you hear me now?
It's still fairly muffled.
A little muffled. Hold on. Let me just see if I can adjust my audio a little bit. How does that sound now?
It's a little better.
A little better? Okay. All right. I'll go with that. All right. Hi, my name is Gian Mishra. I'm with Verizon, and I will be presenting this draft on variable IADs problem statement on behalf of co-authors. Next slide. So this discussion is kind of has been a topic that has come up, that I've discussed with other folks, working on deploying IPv6, and kind of the question mark that always comes up is the interface ID, and just a massive 64-bit size of the interface ID, and why does it need to be, and then explaining that, does it need to be, and the reasons behind that. But I'm sure anybody here today, in this meeting today, has gotten this question asked many times over the years, and so here, in a discussion, I think it was at the end of last year, this topic came up again, and I think Brian Carpenter as well, and a whole bunch of folks on V6OPS were on the discussion, and Brian had mentioned a possible solution. So in this slide deck, we're going to be talking about the problem statement, and at the very end, the solution that I discussed on 6man, we'll discuss that briefly at the very end. But in that discussion that was November of last year, it was basically it was really about this topic, about having that large interface ID, and understandably you need that for privacy on when you're connected to the internet. But do you really need that for private uses or enterprise use cases where it's in a controlled environment? So that's kind of the big thing here, and why and it may be, if any way possible, that changing or slightly tweaking the standard so we can actually use shorter interface ID for private or enterprise use cases where you are in a controlled environment. Next slide. So the problem statement. So really the big one is like the inflexible standard with having that 64-bit boundary. Like it's a one size fits all. We've had the class 64 bit boundary for years. It's been like that for a long time. Of course, changing it, if we do change it, we have to be, careful that we don't break anything. So having a really robust and solid solution that allows for backward compatibility, that we don't break anything. So that's kind of like the double-edged sword. We do want it to happen. We would like it to change. We'd like to change it, but we do not want to break anything. The big problem, so the issues that exist today with not having that change. And this is something that's existed for many years as well. So VLSM, even though there's discussions about different types of implementation, some use cases where people decide to do SAS64 everywhere, and there's issues with doing so. But I would say a lot of enterprises and service providers do VLSM and go crazy with VLSM. I have implementations where I've deployed quite a bit of V6. Many solutions where I've deployed V6 and I've done VLSM, but I haven't gone crazy with VLSM, but it's been in a controlled fashion with a limited number of masks that I've used. But when you're doing VLSM, especially when you have hosts sitting on that subnet, it's really impossible to have DHCP-V6 only devices on a subnet, or static only, or Slack. You're always going to have a mix of all three. But what ends up happening is, if you have a Slack device and that Slack device has that 64-bit fixed boundary, now those DHCP-V6 devices, as well as anything on static, you're really stuck. Everything is kind of hairpin, and really, you're basically shackling DHCP-V6 and static to maintain that /64 boundary. So that's really a difficult situation, and we've lived with that for a long time. This next bullet is an interesting one, and this is really a reality. And there are a lot of operators that have the situation where they have their provisioning systems are fixed, and they're fixed at /64, and they cannot change them. It is very, very difficult, and it's been set like that for decades, and it cannot be changed. And that's with fixed broadband, and for mobile broadband, quite a lot, and in some cases, both fixed broadband and mobile broadband, both are fixed at that /64. So if you want a sub-10, there's no way to do it because you're stuck and you can't subdivide that /64. So that is a serious problem. And then these other topics, we've discussed this quite a bit on mailing lists, but home and so offices trying to be able to sub-10 as well. You got a /64, you need to break it down. And then 3GPP with V2I, V2V, V2X networking, 6LoW IoT devices, and then the last one is ISP backbone POPs, where the NCE attacks, having that exhaustion and distributed denial of service attacks against the neighbor discovery cache. Next slide.
Young, you may want to control your time, as I remember you have 24 slides, and we have another presentation update.
Okay, thank you. So I'm going to try to speed through this. So there's a bunch of other possible solutions that have come up, to extend this /64-bit boundary and other possibility. But the big problem is kind of really that lowest common denominator issue. And throughout these next set of slides, are going to be really talking about the same thing. It's basically that because provisioning systems, they are stuck at that /64, we need to be able to subdivide or be able to actually be able to subnet, past that /64 boundary. Next slide. So as well, 3GPP and RIPE standard for IPv6, allows for, shorter prefixes. However, because of provisioning systems being stuck at that /64, you really can't take advantage of it. You can't actually shorten that prefix, and that's just an issue. That's kind of an issue that exists, and the only way to get around that is actually a very variable length IID. Next slide. This case as well. So DHCP-V6 prefix delegation with the modem manufacturers. This issue has existed as well. That they've got their firewall on the modem devices. They're not able to allow the DHCP-PD packet get blocked within their firewall. So you're not able to you're not able to get a shorter prefix from using DHCP-V6 PD. However, that issue cannot be really, even if you went shorter, that doesn't resolve the issue, because now you're still stuck with this lowest common denominator, that issue with the MBB and FBB provisioning systems that cannot be changed. Next slide. This slide just talks about the use cases, being able to subtend and tethering for V2I, V2X use cases, kind of some details about that, but that's something that, you know, a requirement to be able to subtend, having a shorter IID, but being able to subdivide that /64. Next slide. This one talks a little bit more in detail. I'm just going to kind of skim through this, but it's basically the V2I, V2EK use case and being able to subdivide that /64 subnet down, and being able to do that with a shorter prefix length. Being able to do variable length masking, but pass that /64 boundary. Next slide. And this is just another use case, but this was just /64, and then extending that /64, being able to do 65, 66, but subdividing that network. So if you have a 3GPP mobile broadband, and getting it /64, but being able to continue to subdivide that prefix. Next slide. So this is the 64 share, and then I think a future version of 64 share V2 had been talked about in the past, but that as well, you know, that's still going shorter, and we can't really go shorter because we got these fixed provisioning systems. Next slide. So these next few slides just talk about VLSM. So VLSM is a reality, and I'm just talking about everyone familiar with this /127. You know, I think before it was something to be harmful of not to use, but /127 are proliferated. You know, every service provider does that on point-to-point links. It's pretty widely used. Next slide. And using a /64, of course, you end up with an NC exhaustion issue and possible denial of service attacks. Next slide. And this is just kind of going into still more detail about the NC exhaustion. Next slide. So just talk about the reality of just with this draft, RFC 7381, just talking about the reality of VLSM. So VLSM is used; it's used quite a bit, and it's something that operators definitely need. Next slide. And just just kind of highlighting, you know, being able to subdivide and being able to variable length mask. It's really important, not just on point-to-points or other infrastructure links, but as well user subnets. Next slide. This is just a typical provider network. So like you have service provider network, we have point-to-point links, 127s. You may have an IXP NAP, and you may have shorter. You know, you would like to have a shorter prefix, less than a /64, and then there may be cases where, let's say, in a data center, you have data center subnets with server clusters, and you may want to do a /120, 112. It's kind of that discussion, that really being able to have variable length masking capability with VLSM. Next slide. And then this is the last one in the main part of the slide deck is really the problem would be having Slack, you know, shackling DHCP-V6 and static. You know, now you're stuck. You're going to have, no matter what, you're always going to have a mix of these three types. You're going to have DHCP-V6, you're going to have static, and you're going to have Slack. But with Slack being stuck at /64, it really makes DHCP-V6 pools. You're stuck at 64 as well as anything static. So you really kind of hairpins any other addressing scheme, you know, due to Slack. So, and that's something that we've lived with. Operators have lived with, you know, since the inception of IPv6, and it's really something that really needs to change. Next slide. So this is just going. So I finished the discussion over the problem statement, and I'll see whatever I can kind of go through. I talked about this on the 6-man. But what I'll do is I'm going to try to get to the meat of it. So in this solution, the variable IID, really the crux is that we want to ensure backwards compatibility. We don't want to break anything. So what we're doing is we're using the PIO field. So it's a reserve 2 field, 32-bit field, and just 6 bits of that reserve 2. The goal is that we would just do a slight tweak of the current standard. So we're only going to allow the /80. We don't want to have a race to. We want to eliminate any race to the bottom concern. So we want to just adding 6 to 16 bits to the prefix and reducing the variable ID down to from 64 to 48. And so with that reserve 2 field, we're using that to signal the length. Next slide. So how we do that is, so on any link where the variable ID exists, what we would do, what we want variable ID, the network side, it would actually signal that by sending in that reserve 2 field, that's 6 bits, it would send that in the RAPIO with the 8-bit set. And then this way it would override the values defined in RFC 2464 and 4291 for prefixes concerned that are being advertised. So any prefix that you want to advertise with that variable length would be signaled with the length field encoded into the reserve 2 field 6 bits. So when that variable ID specified in that 6 bits is sent, it's signaled to modified hosts that support variable ID. And so those are the only devices that would act on those 64-bit, that 6-bit field, and now would see a longer prefix, and now it would be able to adjust its interface ID to that shorter length. And so the recommendation here is basically to put that 6 bits into the reserve 2 field of the PIO. Next slide. So here, when in the reserve 2 field, so what would happen if you have all zeros? That would be in 64-bit length, so no change, fully backward compatible. And now if you have anything that's less, so what we would do is any values less than 48 bits would not be allowed. So we'd have 001100. So that's encoded as a /48. So then that would prevent the race to the bottom. So we would not allow anything. So the prefix would be 64 to 80. And the IID would be a maximum it would be a minimum of 48. We wouldn't go any smaller than that. And then just to give an example of, let's say if you had a /69 and the network was signaling a /69, you would have a 59-bit IID, and that's encoded in this length field. So that 6-bit field, we're encoding that in here. So this allows that we're able to signal from the network, and we're eliminating any possibility of any backward compatibility issues. Next slide. So some operational considerations. So unmodified hosts are hosts that are legacy hosts. Modified are ones that are upgraded. So unmodified hosts with modified routers, there's no change. Everything uses the 64-bit. Modified hosts with unmodified routers, no change as well. And modified hosts with unmodified as well, no change. So only if both sides are supported, so the router side is upgraded, the host is upgraded, then you can configure longer prefixes and only down to the /80. Next slide. I believe this is the final slide here. Next slide. So this is an operational consideration. So we don't recommend using a mix of routers that are modified and unmodified. And this is something actually, I don't know, Brian, if you're on it, maybe you could help chime in on this piece of it, because I think this one myself didn't completely understand, but maybe you could help explain this one with the modified and unmodified hosts. Brian, if you're on. Brian Carpenter.
So you're at the end of your time, and we have several folks in the queue.
Okay, that's fine. That's fine. I'm ready for any questions then. Thank you.
Okay. So I think we should probably do the quick questions here.
Go ahead.
Move on to our next.
Sounds good.
Hi, Bob Hinden here. So I have looked at this and the presentation and the documents. So I'm having a little trouble knowing where to start. I'll start with, there are many factual mistakes in the document and in the presentation. SLAC does not define a fixed boundary. You said this multiple times. The boundary is defined elsewhere. SLAC is variable length. It doesn't use 64 in the document anywhere. So a lot of the premises here are wrong. There's also, it seems to me, a lot of circular thinking here. There's a lot of examples about why something new is different, because some implementations, I think you mentioned 3GPP a lot, are fixed, have somehow implemented /64 as a hard boundary. But that's an implementation. It's not a protocol problem. It could work otherwise. And the circular thinking is that you're proposing to change the protocols, but that's not going to automatically fix all of those problems. So I think it's sort of you're saying it's a hard problem, we need to do something different, but then assuming it's going to be fixed and change anything, I don't think that works. The other big problem, or one of many, I think there's a long list of things, but I'll let other people go, is that the notion you could have old and new devices on the same link, besides being very fragile and complicated and hard to debug and all of that, that means you get no advantage of the longer prefix, because there's always going to be old devices on the link that fall back to a /64, so you can't take advantage of anything new. So it's really pointless. So I do not support this work.
Eric Wenck. I was about to say what Bob said at the point, because you cannot mix you and all the implementation of the 6-man draft. Other points, you talk about /128 on point to point link. It would be nice as well to talk about RSC 7404 for using link local. This is my favorite one, of course. And a lot of time at the bottom of your slide, you said, we cannot change provisioning systems, but you can change the protocol. I think this is the wrong priority, right? And that's all.
Hi, Bill Fenner, Arista Networks. I saw a lot of requirements like, well, ISPs require like /120s or longers, and also the problem statement said neighbor discovery cache exhaustion is a real problem. So we're changing it from 2 to the 64 down to 2 to the 48, and that's going to solve the neighbor cache problem. It's not. So I think you have problems that there's no way that the proposed solution is going to address.
Lorenzo Colletti, sort of wanted to second what folks have been already saying. I mean, my main concern here is that the basic premise is that that this avoids the race to the bottom is not true, I think, right? This is not avoiding the race to the bottom. It's the first step in the race to the bottom. We're swapping 64 with 80. And if we think that, ISPs that, right now hand out the minimum, which is /64, and there are ISPs that do this. If we think that these ISPs are not going to switch from 64 to 80 once everything supports 80, we are sorely mistaken. The decision to provide the minimum amount of address space is a business decision. We have talked to those folks. We know how they feel. Some of them are in this room, right? And so we should not delude ourselves that changing the minimum size will result in the ability for users to subnet. It won't. It will just result in the minimum size changing, right? So I think we need to really think about that.
Tobias Siewich, Max Planck Institute for Informatics. I'd like to echo some of these statements. So especially the example in the draft that talks about neighbor discovery cache exhaustion in IXPs in the draft. Feels a little bit artificial, given that on an IXP you do have a relatively fixed number of people connected, and you have a very strong sum on like whose MAC address is on there. So the growth of that network is basically determined by the number of members. So the case that is made doesn't really fit, and that ties in with the general confusion. So it seems in the draft a lot that it's confusing between what is relevant in access and what is relevant in the core, which just goes through it. Also the tie-in with various recommendations from the RIPE region on how assignments are to be done are somewhat difficult in there, especially given that in the RIPE region we are facing problems, or we are facing fears that if you, for example, have a more relaxed IPv6 PI assignment policy, people will start running ISPs on a /48, which then ties in with Lorenzo's observation that if you give people the ability to have a /80 or longer, they will go for that.
So we have one more to go. I would encourage folks that want to talk about this to bring it onto the list, because we have one more presenter, and I want to respect the amount of time that we can give him.
All right. Thank you. Thank you for all the comments. Appreciate it.
Hi, my name is Patrick Rohr, and I'll be talking about array lifetime metrics that we've collected in the wild. And I would also like to apologize right away that this talk is not particularly refined. I made the mistake of presenting these metrics to Jen and Lorenzo this morning, and here I am. So, next slide. So why do we care?
All blame is entirely mine. If any mistakes are made in this presentation, it's my fault for telling Patrick, hey, you should present in 15 minutes.
Right. So why do we care? So for mobile devices, processing arrays is actually pretty expensive. The CPU needs to wake up, and especially so low array lifetimes, which cause having to send a lot of arrays within a short period of time, have an outsized impact on battery life. And array filtering offloads have to be based on the lifetime of the array. So that determines, so sort of how much battery we can save. So for right now, what Android does actually is we filter for the 1/6 of the renewable lifetime of an array. So if you get an array with lifetime 180 seconds, then we can filter that array for 30 seconds. And this becomes even more of a problem now that we have multiple array sources in the network with the advance of thread routers sending arrays as well. Next slide. How do we do this? We collected array data on Android 11 Plus devices. That includes devices from multiple OEMs, most Android devices actually. It only includes networks that receive one distinct array, which sort of hand-wavy maps to a single router. We do like a partial byte match. We ignore some lifetime, or we ignore lifetime sections and some other things. So it's a bit hand-wavy. And for a given array option type, only the lowest lifetime value is recorded. So if you have multiple RIOs, like 180 and 1800, then we record 180 for the lifetime of the RIO. Obviously, zero lifetime values are not recorded. Next slide. So this is probably the most interesting slide as far as our array filtering offload is concerned. This is the lowest value between the router lifetime, the PIO valid lifetime, and the RIO lifetime. It's a bit rough. So the second value is sort of an implementation detail / bug. We report, if router lifetime is 0, we set it to int max. So presumably this means that the second value here means router lifetime is 0, and both PIO valid lifetime or RIO lifetime are larger than that value. So they are probably set to uint32 max, presumably. I assume there are not many values between 2 billion and 4 billion that make a lot of sense. So we see that 180 seconds is actually quite common. That's the 14.7th percentile here. Surprisingly common 30 seconds, which is incredibly expensive and probably does not work. Next slide. This is just the router lifetime, so the distribution is actually quite similar to the previous slide. I'm not sure if there's anything that's specific we should call out here. Actually, a lot of networks seem to be using the RFC 4861 default of 1800 seconds. Slide. Here we have the PO valid lifetime. Those values are larger as we would expect. Actually a lot of uint32 max values there, a lot of infinite values. Next slide. And here we have the RIO lifetime values. And there's actually a surprising amount of RIO lifetimes, 23% or 22%, which set it to 180, which I don't know if the thread or the snack draft makes any recommendations, but maybe we can raise this. I don't know. Next slide. And here, somewhat related, we have some metrics on DTIM period. It's somewhat related because the DTIM, I don't know how familiar you are with client-side DTIM skipping on mobile devices, but essentially what happens is mobile devices do not wake up for every DTIM broadcast. Usually they skip they only wake up for every nth DTIM broadcast. And a lot of times this is dependent on the DTIM period configured on the AP. So here, I guess one thing to note is host appd actually sets defaults of DTIM period 2, but it does not seem to be the most common value. So I guess presumably AP vendors configure this to 1 because they think it works better. I don't know. DTIM is the period in which a Wi-Fi AP sends broadcast traffic. So yeah, all Wi-Fi devices are expected to wake up on that period and listen to the broadcast. So it is actually, the period is multiplied by the beacon interval, which is usually 100 milliseconds. We do not have metrics on that. Presumably it's 100 milliseconds. And next slide. One thing, I guess, before I take questions, I would like to mention is that we also have upstreamed a sysctl accept array min lifetime, which we are hoping to set to 180 seconds, which will then cause to essentially the kernel to ignore any array lifetime or any array section lifetime that is below that value, except 0. But we're looking on feedback on that. So if you have a better idea of what value we should set it to, let us know. All right, questions?
Yeah, basically not a question, sort of like not to you, but sort of a statement to the room. I think one thing to point out here is that I don't know what other OSs do, but Android kind of folds over itself. It's like some super complicated filtering logic to make sure that we like listen to enough of these that we don't fall off the network, but we still allow the network to push configuration changes. Because if you can't push configuration changes, you can't change anything, and if you can't change anything, you have to do NAT. Remember, like this is how it works in IPv4. We don't have to change anything, so we have all of these static configuration protocols like DHCP, which can't be changed, and we survive because we have NAT, right? So I think it's very important that we actually are able to. Now the problem is there that all of these low lifetimes are very expensive battery-wise. So I think and we have this tension where Android device manufacturers are incentivized to increase the DTIM skip from 3 to 5 or something because listening to the beacons is expensive. And that in turn causes them to fall off IPv6 networks, making IPv6 less reliable. Cable operators especially have reacted by increasing the frequency of arrays, which means that it's sort of like this death spiral where we get more arrays, device manufacturers drop more of them, and so on. I think we need to sort of see what we can do as an operational group to increase these values over time. Maybe we can issue recommendations to home router vendors, or maybe we can sort of use things like the thread certification program or works with Matter or whatever marketing incentives to at least increase these values. One thing that we are doing as Android is we put this line in the sand: if you're less than 180, we don't care. It's v4 only. And so that's something that maybe other vendors could consider whether they want to do that as well. Because less than 180 is really just impractical from a battery perspective. So yeah, just wanted to say that. And as a working group, we should consider, we're open for a like 7084 update. Maybe we can say something about DTIM, or maybe we should find out why people set DTIM. I know that Apple was strongly arguing, or Apple folks were strongly arguing for setting DTIM to 3 on access points. No one seems to do that. Maybe we should find out why, right? So.
Janikova, I quickly look at the data. I might be confused. Like we discussed, 300 is very low lifetime, right? I can understand that operator might might set router lifetime and PIO lifetime to the same value. So if your router disappear, your address disappear. But if I'm not mistaken, you see more data points with 300 PIO lifetimes that you see 300 router lifetime. So it probably means like in some cases what like PIO might be even like shorter than router lifetimes. That's like interesting. I don't have any explanations for this, just curious. Yeah, what could it even mean?
Yeah, that's an interesting observation. Hi, Tim Chand. Yeah, this is very interesting. Thank you. I wouldn't know without looking what the various RFCs say about what those values should or must be, but I will go and look afterwards. Two things that come to mind. One is we're just restarting a revision of the IPv6 node requirements, RFC 8504. So that might be a place in which we can put some of this sort of stuff and thinking in. The other one is that there was a green BOF earlier in the week, and I wonder whether there's a draft in V6OPS where there's a collection of V6 specific impacts on battery life. So it's not just this, there are other things, happy eyeball springs to mind, but there'll be other things as well that are causing a drain, and maybe having some guidance for vendors, implementers about that.
Okay.
Thank you. Thanks, Tim. Actually, I was going to come to talk about that, right? So back in, I think, like 2013 or so, right? Like we found an issue with like some of these things, like on the, especially on wireless links for V6. One of the issues was the max router addressment lifetime was like fairly low. So we updated 4861. I think it's like 8319 or something. There's an RFC, like nobody uses it, right? So like in a roundabout way of thinking on Lorenzo's line, right? So imagine if like we have a configurable max router addressment lifetime, and let's say like Tim puts it in the C router thing, and it stays pretty high, we could kind of turn off the filtering for arrays. I'm just throwing this out, right? Like turn off the filtering for arrays. We can also be responsive for config changes. So because one of the things of filtering the arrays is that the config changes become difficult, right? So if the maximum router addressment lifetimes are high and they are based on packet loss probability. So if Bob can tell you the whole history of this, right? The max router addressment lifetime was set based on packet loss probability. So what we have in this RFC, the 8319, is that like look at the packet loss probability and then figure out what the router addressment lifetime should be so that it doesn't expire when you're losing packets, right? So I think if you can kind of go to that model where you expect the routers to be less frequently sending multicast stuff, you can probably turn off that filtering, get some cycles back for whatever other cool things you do, and then also be responsive to changes because the router can actually do a non-periodic array to kind of refresh the thing quickly. Thanks.
So I think one problem, though, is that you do not know how often or how frequently the network sends you arrays. So you don't know if you can turn off the filtering, right? But the filtering is pretty smart, as in if there's any change in any of the actual data, obviously we pass it. If there's if the lifetimes increase, we pass it. If it switches to 0, we pass it. If it decreases to 1/3 of the original, we pass it. So like there's a lot of logic around that.
Thanks for doing this, Tim Winters, QA Cafe. So a couple things. Obviously, the CE router draft, CPEs are all over the map with this. I'm sure you guys have experienced this, and there are operators who have this idea in their head. One of them I recently talked to said they were doing it every 10 seconds. So I think if, well, they wanted it to, it's kind of ironic, right? And I didn't realize you guys were doing this, right? Their logic was is they had devices that were taking too long to come up. So they just spam the network. So, I caution them not to do this, but not to do that. But I think, definitely in the CE router draft, I think Tim has a good point. As node requirements too, maybe we should say some words about this. Obviously for battery networks, wireless ones, things where things are not plugged in. General nodes, I think we can put some words around that. CE router, I think we should definitely put some words around these lifetimes and tell people don't be crazy about the lifetime and the interval. Remember they're separate, so keep that in mind as well.
Okay.
Warren Kamari, Google, wearing my knock hat. So for people who've been coming to the IETF for a long time, if you remember the Prague meeting, like 3 Pragues ago, people's phones were dying in like less than a full IETF day. You're getting like 6 hours of phone time. And that was almost entirely IPv4 ARP being broadcast everywhere, and your phone would wake up and be like, that's not for me. That's not for me. Some of that was solved because the wireless LAN controllers are now doing all sorts of weirdness and like inspecting ARP and only sending it to certain people. That kind of vaguely works, but it's awful to debug and the network behaves weirdly. Let's not recreate that in V6. So yeah, let's do this.
So Tobias Siewich, kind of uninformed, stupid, quick thought. Isn't there some room for the end devices to just heuristically adjust how much they ignore in terms of like packets, arrays coming by? As I said, like stupid idea. Like starting with following too low recommendation of a network, and when you see over time that it does actually not change that much, so that you have a lot of redundant packets coming in, you increase your like filtering rates. But stupid thought. We just
Yeah,
wanted to
but
share.
the problem is that there's also DTIM, so you're only receiving a certain amount of packets. So I don't know. Also, yeah, maybe could work.
Lorenzo, do you think you could get an update of 7772 with this data? And more pieces to it?
Yeah, I think I'm sort of to blame for that. It was too optimistic in hindsight. The other thing that I think was also got stuck is that we're talking in 6-man, what was at the time Fernando's doc around, Slack renown was like, it was like recommending lowering the lifetimes. And I sort of realized a bit late that, DTIM basically just makes that a big problem. So yes, we do need to publish more guidance, but I think in general, I don't think, that document had much of an effect. I mean, I suppose it gives Android grounds to say that 180 is just the minimum, period. We can point to that doc and say, look, it's clear that you're doing it wrong. But I mean, I don't think people are really reading that doc. So, I mean, yes, I agree. We should sort of update with new, with new recommendations
I'll
once
tell
we
you,
have
I did, and a lot of people in my community that run massive Wi-Fi networks did.
Okay, thank you. Yes, I agree that we should update it. When we should have more general recommendations, I think. One thing I wanted to say is for those people who are, one thing I wanted to say is that for an OS like Android, which is sort of relatively sort of well-funded, right? Or well-funded, let's say, it is possible, although difficult, to build filtering that will actually accept the right packets and drop the packets that we don't need. This is what APF does. It's very sophisticated, very complicated, but it can be done. The thing that just cannot be done is survive random packet loss that is imposed by design by the Wi-Fi chipset by skipping 50% of packets. And one thing that I'm sort of a little bit, one thing that's unfortunate about this is that we as a working group don't have a lot of control over that. So I'm looking at people, people that have maybe associated with consumer facing things like Matter or Thread, TED, and, or whatever, whoever else, right? Is like, if we can't fix the DTIM skip problem, we really have no good options here. There's no amount of smart code on device that will do this, because the DTIM skip is just like, I'm going to drop 50% of packets, or I'm going to drop, in the case of many well-known Android device manufacturers, I'm going to drop 80% of multicast. When you're dropping 80% of multicast, there's no amount of smart code that you can write that'll make your device work well, because statistics are just against you. Right? Because the 80% loss, you might sit there for an hour and drop all of them, because the dice comes up like, between 1 and 4 every time, right? So I think, we really need to try to tackle this DTIM problem. And I think maybe getting the sort of the recommendation to do DTIM to 3 on APs would help. But I think we need some sort of like marketing initiative that CP vendors actually care about for that, because it's not really in scope for, even 7084 could say this, but it's just sort of difficult to test. So, but maybe we could test it in 74. Anyway, DTIM is the problem here, is the main problem.
Yeah, sorry, Jalinkov, I know the queue is closed. I just want to comment, 7074 was very, very useful. It also suggests a unicast solicited arrays, which actually moved the needle and forced a lot of vendors to do it, right? So I would not say it's useless, maybe just recommendations in other cases needs to be like more solid, so you can go to vendors and ask them to do this.
That would be the last presentation. I would also like to mention there are a few documents that are in various states of last call adoption that I would encourage folks to go read and comment on, so we can progress those or not based on the conversations.
We are going to announce a long list of inspired document in the working group as that documents, because some are as old as 2003. So if you feel that the work is useful, please resubmit your work. If you need somebody to review it, please send the chairs a message and we'll try to help. This is one thing. Another thing is that in the afternoon from 3 to 4:30, we are going to have a side meeting. Tim Chow is going to discuss the IPv6 deployment and operation issues in CERN, one of the biggest European research network. So I want to let you know it's in the Prince of Wales. If you have time, please join the side meeting or dial in. Thank you and see you either here or in Dublin.
We've got a couple of drafts I think we probably need to push into adoption call.
Yes.
He's got two. Yes.
Yeah.
Make sure you figure out that.
Thank you.
I just want to make sure you guys knew it's in the wrong state.
Yeah. I
thought I missed it, and then I was like, no, I did my half. So you guys.
Yeah. So maybe this is a question for you that can answer, because I'm new. I don't know. Like, since I'm an author and he's an author, is it?
You are just a work military, so you should change the state.
I know we can. I don't know what the, like, is that acceptable being conflict of interest or?
Right, so it's like, hey, the write-up's in, and then it goes to ISG. So you're just
Okay. So it's okay for us to do it even though we are authors.
Yeah.